Ladies and gentlemen, welcome to my shop. My name is Keith. I'm your host. Let's start off with the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. On with the show. Okay, we're changing it up today. We're actually going to start on a repair for ourselves. The Clausing Lathe here, we have talked about it in the past when we were over at the other location, and many comments are asking, hey, when are you going to do that? When are you going to do that? Okay, we're going to address the cross feed and compound feed clearance, slop, play. I like to call it free space. This is a 1957 Clausing, same age as I am, and both of us are getting on the age, and our nuts are still functioning, but they're sloppy. Okay, they got the free space. All right, now if you pull back on your compound, the compound's in this direction here, so if it was 90, I wouldn't be able to do this as well, but you know, it's 60 degrees or 30, however you want to look at it. So we're somewhat in line there, but I'm going to show you the combination of the play in the compound and the cross feed and what I actually have here. All right, and the free space, I call it free space because the load is in the one direction here when you're feeding in or in the direction of feed, and then when you're cranked back and or return, you've got that play, so you can hear it and you can probably see it. And we'll bring you in closer and we're going to actually show how much that is. We're going to double check this with an indicator, but for right now, we're going to go ahead and we're going to back this up more than one turn, and then we're going to set it up on 0. And we're going to do the same thing here. We're going to set this one up on 0. Now, that's pulling the lead screw or in the reverse feed, but this brings us up to the 0, and then when we go to turn it into the feed, it'll be showing us the free space between making contact on the back and before it catches the other side of the lead screw to give it the push. Okay, so we have free space right here. In fact, actually the dial, if it was weighted, you know, any different, it would take up that travel. Okay, and right there it stops at 34. So you got 0, 34. Here you got 0 and 47. 0, 47. So we have about 34 there and 47 thousandths combined between the two of these. Now let's set up the indicator and we'll be able to push the carriage back and forth, and we should see relatively 34 and 47 thousandths of an inch in movement. I'm going to put the mag base down on this part of the apron. The apron's what guides on the ways of the lathe and supports for the crossfeed and the compound, and in this case the tracer attachment on that side. Alright, so we've got that locked down there, and that gives us independent support other than the cross feed and the compound. And then we're just going to put the indicator here. See, we're going to pull it back towards us. Alright, so we'll be able to set our 0 right there. The compound slides easier. The compound slides easier than the crossfeed. Alright, so the first motion here, we're going to notice how much play is in the compound. And right there we got 33, and then I push it harder, and then we get the other 45. So we have in this position right here, for, you know, if a tool bit contact with the rotating part on the in and out, we've got 83 thousandths of free space that that tool bit can go anywhere it wants to go in regards to either sucking in or dulling up and tool pressure pushing it out. Just depends on what application you're running your tool bit for, inside, outside, face, or whatever. Okay, so now we've confirmed that amount of play in those two areas. The compound about 34, and we got about 47 on the cross. And we pull back and we're back to 0. Alright, let's start taking the thing apart so we can get a good visual down on those individual parts themselves. The lead screw and the lead nut. I think we'll go ahead, we're going to take out this pattern here and put it up there. Okay, and I think we're going to need 1 or 2 straps on here, and I think we just strapped it like that, and then this strap here. Yeah, I think that was our easy way. Okay, we're ready to go there. Let's go ahead and get our bit, and we'll undo our screws that hold that on. Okay, there's 4 screws that hold the tracer attachment on. There's 2 underneath, and there's 2 right here. And we better put the hook on here before we do that. Okay. And it can just hang there, and we can move this back out of the way. Alright, let's go ahead and pull off our tool post, and then we'll undo the cross feed. Okay, 3/4 inch wrench. These actually lift the compound up. There's not enough clearance for the nut to go up over the stud before coming completely off. So you just crank them equally, and then they become off the top, and then they stay right in the pockets there. Alright, and then we're going to set this down in the carriage, or the pan for right now. Okay. Alright, and I believe we got the nut right there, or bolt in the top here, and I believe we undo that, and we can slide this right off. We'll probably have to lightly remove the tension on the gib, but we have these bolts in here that hold the gib and the screws on this side here that run the tension. We're going to just try to leave it alone for right now because we want to slip this thing off, check the nut and the lead screw, and then slide it back on after we have our drawing. Alright, I think I got the right socket. There we go. Okay, passage for the oil. And that goes right down into the center of the nut. Alright, now that should be loose from the crossfeed, I would say. And it is, okay? I can see the nut disappear from underneath it. Okay, I'm going to go around the other side so I can pull this back. Now, I know it's going to go a ways before I actually have to touch it. And actually, it might not have to go all the way off. I'm going to go ahead and see if I can just push it past the nut here. There we go. We're not actually going to have to remove that. When I bought the lathe, it had a couple pieces of damage to it. One, that chunk that you saw missing on the compound top, and also this chunk right here. This chunk had to be broken off when either the carriage was in past that point or with this off of here and something was dropped and broke that. When I first got it, I did a lot of stoning, and of course I've never filled that in, and I've had a lot of success with some ways, and I do on the K&T. I have a section where I filled that in with Marine Tex and then hand shaped it, and I was able to keep it so things don't get caught into it. I'm always conscious of this, and I keep it clean, and I try not to drag stuff back and forth through here. So, but that is a knockout in there. You can't go backwards in time and and slap somebody off the side of the head. Yeah, that's what that 47 thousandths 47 thousandths, and then you look at the lead and you can see the space in the actual thickness of the thread itself and how much left of that thread is it actually there. So we're just sticking the scale down in here. So basically you know, kind of I'm looking down there at the root of the thread or the top of the crown there. The root might be something like, I don't know, 100,000, maybe 90,000. So our slop in this nut is pretty close to half of the thickness of the thread itself. I'm sure that when I first got this, I adjusted and got some of that play out because there's adjustment right here. But I think it's time for a new nut. So we're gonna measure the pitch of that and the diameter, and we really should crank the nut all the way off so we can draw the nut. We're gonna need to fabricate that nut. We decided to try. We're not going to pull the nut and the hand wheel and this bearing, thrust bearing end of the lead screw. We're going to go ahead and undo the two bolts that bolt it to the apron, and then we should be able to back the nut out and still leave that on. Don't really want to mess with all that tensions and everything else on that for right now, because all we need to do is clean up, make a drawing of that nut, measure the lead screw, order what we need to order. Alright, so now this should pull back, and we undo She's pretty thin. Yeah, she is. Alright, let's get her wiped up and blown off. I've just got my dummy calipers here, and I'm reading like 748. In the middle here, I'm getting like 751, and the reason why it's mushrooming, the contact area has been mushrooming, so the diameter is growing, and we're basically hitting a little raised lip here. Alright, and we got about 748 on the other end there. The other way we're going to look for just a little bit of wear on the lead screw is we're going to hold the calipers not necessarily in all the way, because we don't know if all the way is the root, but we know that somewhere around the working pressure depth, halfway down or so, by holding it at this angle, we got like 108. This is no science, okay? We got 100, 99, 96, 93, 100, 96, 102, 107, 104. But we think most of the wear is at the pretty close to the crown of the top here. See, there's 85, 81, 84, 82, 79. There's one little area, 83. There's one little area in here that's a little bit more worn than the rest of it. It's like in this little section right there. Okay. When it comes time, we'll dress this lead screw up here, and then we'll decide if we want to take. This is not enough wear on this by just inspecting right here that it worthies building a whole lead screw. But we may come in and set this up and chase follow it so that we make sure that we've got a uniform thread, meaning that the root decides and everything else are going to be the same width all the way down, so we can make a uniform thread. We don't want to, we'll be taking minimum. We want to leave it as natural or to regular size as possible. Okay, what size is that? Well, we did measure that at 3/4, basically. And its pitch, we'll get out our ACME pitch gauge here, and it looks like 4 or something close to that. There's a 4 there. 4 looks too big. Let's try 5. 5 fits right in there. 3/4 5. Alright, we're going to look up our availability and price in the book for a 3/4 5 ACME tap. We put our compound over here on this little table by the surface grinder here. We figured it's going to be a good area to work on it. Alright, now we know that this is solid on the end here, and we can sight down this hole, and when we screw this all the way this way here, we see the end of the lead screw is right up against the solid wall in here. This is the lead nut here. There's a set screw here, and there's a little groove there that goes in. There's a thread here for pulling this back out, so we know that that has to come out this way here before the ways and the top can be separated. And the lead screw can't go that way because it's solid, and it can't come this way here because this is where it's holding the thrust. So we have to dismantle this, and we're going to have to pull this nut off here first, then the wheels and everything, and then this retainer probably mounts in the end with a couple Allens like the one over on the cross slide. Alright, so I got my impact here. I'm going to pop this nut off. There we go. And the hand wheel comes right off. A nice spline. Nice spline. Okay, so that's a thrust surface right there. And part of this play, might have been between that thrust. And when we go to assemble this, we're going to be inspecting that, and we may do some kind of shim washer, something to compensate for that. All right, now there is 2 Allens in here, and I believe they're 1/4 inch. No, they're not. Okay, 7/32. All right, now there's the retainer bushing. And we can unscrew this, but we can feel a little bit of play in there. Yes, we can. Okay, there's the lead screw. Now let's go ahead and see about pulling that up out of there, and I think it is a 5/16. All right, and we got an Allen going in there, and that may be somewhere around 1/8 of an inch. Let's see, a little bit bigger. 5/32. Hey, that's it. It wasn't tight either. It's kind of loose. I'm going to see if I can screw this in. I think it's the right threads. Okay, I'm going to go get 2 little blocks and a pinch bar, and we're going to pull that right out of there. All right, we may not need a block yet. Okay. That was like too easy. Couple tool bits. Probably a little tiny burr in there now. All right, or gunk. There's a lot of dirt and stuff down in there. All right, I'm gonna have to get a little bit thicker block. Those were 1/2 inch. Here's some 5/8. I can get underneath the end of this thing here, and maybe I could push it up. No. Probably has a burr from there. All right, we're going to go ahead. I'm going to pull this out of here. We're going to get a piece of a couple parallels, and we'll draw it out of there like a jack screw. I think using that nut and that nut as a post, we're going to take this toe clamp, that'll be the bridge. We happen to have a nice long piece of 5/16 all thread in the cabinet in there, so I'm not going to bother cutting off a piece. We're just going to use it the full length here. All right, and we got a 5/16 washer and then a really thick 3/8 nut or washer there. Act like a nice bushing surface. I'm going to run the tap down in there because those threads just kind of seem a little less than. I felt a little resistance, so I think it was just a little bit mushroom, dirty, old, whatever. Okay, back to where we were before we decided to clean that, and that screws in much nicer. Okay, we're far enough in. Now we should just be able to draw this right out of here. Go get a half-inch opening. We'll probably see that it was a burr on the actual lead from the wear of the years on the Okay, we're going to add some more. We'll just go ahead and take these two 5/8 tool bits here. That'll be enough, or it should be enough. I can start to see the threaded hole. This thing's longer than you think it is. And we thought we were going to get lucky the way that thing popped when it was. There we go. Alright, so basically it's just round with a keyway or locating slot for the set screw so that it'll lock it up and down. And it's free floating so that the alignment going up and down is perfectly fine with the center. And center this bore with there. An easy part to make. Alright, so we're going to locate a piece of bronze for that. Okay, we kind of wiped everything off with a towel here, and let's find out what we actually have here. And okay, that's an 8, and that's 5/8, 5/8 8 Acme, and right hand threads. Okay, here's a general rule that you can always remember. Dials always rotate clockwise, so if they rotate clockwise and you're threading the lead screw clockwise, if you're pushing an object, this is going to be a left hand thread. If your object or your thread is in the movement of the part or the top sliding part, it's going to be a right hand because it's drawing the part through. So a left hand thread is actually going to be working on the outside face of your threads, and right hand thread will be working on the facial side or the face towards you on the threads. Just general rule. Okay, if you look down in there, you can see that it was taking a cut on the crown inside there, all the way around on the threads. So this outside surface of the tap was making the cut for the diameter. Alright, we found a nice piece of, we're going to make this out of Tobin bronze. Tobin bronze is a pretty hard bronze, and for no adjusting type of threads here, meaning there's no slit with a jack screw or a way of means of tightening or adjusting the nut tighter as wear happens, we're going to go with this harder material. We did order a 3/4 5 left-hand tap, and that will be to make this nut here. And this is a 2-stage as well. It comes up with a partial cut here, and then it cuts the rest of the thread out with that. Okay, now it's coming out to the root again. And we're going to go put that in a vise and crank that through. It's the same thing there. I can see down in the root. Probably more so on this one here, it's rolled over threads. Because as it's wearing side to side, it had a little clearance on the root down in there, and the material rolled into the root. And I can see harder scrapes near each corner depth, meaning the corner of each of the threads here, than in the dead center of the thread. But that thickness of those threads in there is paper thin. This nut really was getting to the point. I can deal with the play, but I wasn't dealing with the thought of stripping this nut out during a cut on a pretty good job. That's kind of where my head was at. Alright, we have that little chunk right there for this piece, which is, I believe this is some 955, 954 type of bronze that I bought for some way wearing plates at one time. And I think it's definitely big enough to create this. So I sawed this out of a little bit larger block, but to get it down to where it was pretty close to part size. And now we're ready to head into the mill and start machining this nut. And we'll get the other round piece into the lathe and we'll start machining that, and then we'll both meet up in the mill to put the final threads into it. And then we'll come back, and after we have the actual ACME threads in both of our nuts, we will address our shafts, take off the highs, the burrs, and anything that we don't need. And we're going to check the fit, and we're going to talk about the fit and what I'm going to allow and what I'm going to put it back together with. Alright, new announcement. The best ball caps in the community are back in stock right now. Now, anybody that's worn one of my Adams caps with the cool lining, adjustable strap, knows that I'm walking the talk and I'm getting her done on ball caps. Now, there are a couple new changes to the ball cap. On my turn right ball cap, I'm offering it now in a solid color. We're doing them in black and we're doing them in navy. Now, we carried over the same cap, the same great ball cap, the Adams cap, with the Patriot Attitude artwork on the front. And the emoji I was using at the time when I designed this ball cap is still on the side of it. I like it. I'm going to continue with that same style right here. This is the black. I also have it in the Mississippi Mud. I have it in the charcoal. Charcoal's pretty close to the black, but it is a little lighter. These are stone finish ball caps. This is also in the navy as well. Now, at the last time when we came out with the Patriot Attitude, we had several camouflage caps, and the most popular ended up being the XD3 made by Pacific. Okay, this hat doesn't, I'm not sure if this hat floats in the water. I haven't proven it yet, and I'm not going to claim it does, but I am going to claim it was the most popular camouflage hat at the time, and we offer the Patriot Attitude in that as well. Alright, I just wanted to bring you up to speed and let you know that I have the ball caps back in stock.